Assalamualaikum warahmatullahi wabarakatuh. I will do Dr. Azhan. We are from Group 2. We will present about experiment 4, application of first and second law of thermodynamics. This is our teammates, Muhammad Azhan, Umar Irfan, and me, Nurul Afifah. Introduction for this experiment. First law of thermodynamics, known as the principle of conservation of energy. As we know, energy can be changed and transformed, but it cannot be destroyed or created. For example, photosynthesis. Photosynthesis in green plants use energy from sunlight to produce their food. Through the process of photosynthesis, which is light energy, is converted to chemical energy. And the second law of thermodynamics, energy spontaneously transfer from higher level to lower level, but it can be occur from lower to higher level by adding a pump to supply energy. Objective for this experiment has only one, which is to apply the first and second law of thermodynamics in various processes. Scope for this experiment to discover on how the experiment demonstrates the conservation of energy, which is first law of thermodynamics, as energy is transferred from the hot coin oil to the cool water until reach equilibrium temperature at 3.5 degrees Celsius. Second one, to study on how the experiment illustrates the increase in entropy, which is second law of thermodynamics, as the hot coin oil loses heat and the cold water gains heat within 1 minute until both hot coin oil and cold water reach equilibrium temperature. And third, to study the energy change in the hot coin oil from 89 degrees Celsius and in the cold water from 4 degrees Celsius until both reach equilibrium. Theory and working principle. Theory for the first law of thermodynamics. This law is also known as the law of energy conservation. It states that energy cannot be created or destroyed in an isolated system, but it can only change forms. In other words, the total energy of an isolated system remains constant. Mathematically, the first law of thermodynamics is delta U equal to Q minus W, where delta U is change in the internal energy of the system, Q is heat added to or removed from the system, and W is the work done by or on the system. Theory for second law of thermodynamics. Entropy is a measure of how disordered or random a system. We have two fundamental statements. Clausius statement: heat naturally flows from hot to cold, not the other way around unless external work is done on the system. Kelvin Planck statement: no machine can take heat from one source and convert it all into work without using multiple heat sources in a cycle. And heat naturally moves from hot to cold, and not all heat can be turned into work in a cyclic process. This statement highlights the one-way nature and constraint of thermodynamics process. Formula for the second law of thermodynamics: delta S bigger than or equal to Q divided by T. Delta S is change in entropy, Q is heat added to or removed from the system, and T is absolute temperature for the system. Entropy is crucial to the second law. It asserts that in any energy transfer or transformation, the overall entropy of an isolated system will consistently rise. And the picture is the example for the second law of thermodynamic system. For experimental setup, this is the apparatus that we use in this experiment. For this experiment, we use corn oil as a medium. So we have corn oil, magnetic stirrer for balance heating, hot plate magnetic stirrer, electronic scale for weight the beaker, container, thermometers, beaker, retort stand, and stopwatch.
Okay, next I will present about the methodology. Step 1, switch on the plug. Step 2, weigh the small and big beaker. Step 3, pour the vegetable oil into the beaker. Step 3, pour the vegetable oil in. Step 4, heat the beaker containing the oil to be specified temperature. Step 5, put the small beaker into the big beaker containing ice. Step 6, record the data in every minute until it becomes equilibrium. Step 7, switch off the plug after finish the experiment. Step 8, wash all the apparatus and switch off the plug. Step 9, put all the equipment in the original place.
So we continue with the result and discussion. Okay, this is the data that we use in this experiment, which are mass beaker with corn oil, mass container, oil volume, and others. Okay, this is table 1. This table show time, temperature of cold water, temperature of hot corn oil, temperature difference in cold water, temperature differences in hot corn oil, energy change in cold water, and energy change in hot corn oil. Okay, for the calculation, first, mass of cold water equal to mass container with cold water minus weight mass container. And we get mass of cold water equal to 0.4117 kilogram. Second, mass of hot corn oil equal to mass beaker with corn oil minus weight mass beaker. And we get mass of hot corn oil equal to 0.07705 kilogram. For the temperature difference in cold water and hot corn oil, we use the same formula, which is T2 minus T1. 5. Energy change in cold water. We use the formula mCp delta T. And we get the energy change in cold water equal to negative 0.86 kilojoule. For energy change in hot corn oil, we use the same formula, which is mCp delta T. And we get the energy change in hot corn oil equal to negative 11 kilojoule. Okay, this is the graph that we have plotted in this experiment, which is graph of temperature of hot corn oil and temperature of cold water versus time. According to graph, the hot corn oil show negative gradient, while the cold water show a positive gradient after 21 minutes. Both hot corn oil and cold water reach equilibrium at 28 minutes. Now, we continue with the discussion. Okay, this experiment is successful when the temperature of the cold water and the hot corn oil are in equilibrium. While experimenting, it observed that the temperature of hot corn oil dropped more rapidly at the beginning stage compared to the temperature of cold water, which slowly decreased and slowly increased at the end until after 28 minutes, where both hot corn oil and cold water achieve thermal equilibrium. The transfer of energy between these two medium obey the first law of thermodynamics, which the total energy of an isolated system is constant. Hence, energy can be transformed from one form to another form, but can be neither created nor destroyed. The gradient of graph represents the rate of temperature change from the beginning to the end of the experiment. According to graph, hot corn oil release energy as it shows a negative gradient, while the cold water absorbs energy as it shows a positive gradient after 21 minutes. The magnitude of gradient depicts that hot corn oil releases more energy compared to the energy absorbed by cold water. This is because a bigger mass of cold water used compared to the hot corn oil. Besides, the temperature of hot corn oil decreases while cold water decrease and increase as time pass by. It shows that the heat transfer obeys the second law of thermodynamics, which heat is transferred from high energy level to low energy level. Finally, due this experiment being conducted in an open system, not all energy from the hot medium is transferred to the cold medium. Hence, some energy in the form of heat may be lost to the surrounding. So next, we continue with the conclusion. Okay, in this experiment, the change in energy for hot corn oil is a negative value because the energy of hot corn oil is transferred out from the hot corn oil into the cold water, while the change in energy for cold water is almost achieve a positive value because the cold water receive energy from the hot corn oil. The change in energy for the whole system, which is supposed to be zero, is negative 11.86 kilojoule. This is due to heat loss to surrounding. Therefore, the first law of thermodynamics, which states that energy cannot be created or be destroyed, but it can transform from one form to another form, is obeyed in this container if the container is well insulated. Besides that, it is found out that the heat energy is transferred from higher energy medium to the lower energy medium, which is the second law of thermodynamics is obeyed. So we can conclude that our experiment is success and achieve the objective.
Next is possible error. First, temperature readings are not accurate due to very rapid changes caused by the environmental factors. Next, thermometer reading error caused by the eye not being perpendicular to the meniscus. Next is the improvement. The first one is ensure that the laboratory conditions are in a suitable condition to ensure that the temperature of corn oil does not change rapidly. Next, make sure the eyes are perpendicular to the thermometer reading to avoid error. Next, I will present about the safety procedure. The first one is the laboratory safety. First, always wear a complete attire that covers the body, which is a lab coat and protects your feet. Second, hair in a neat condition for those who are free hair to avoid distraction. The third, do not chew gum, drink, or eat while working in the lab. Next is the equipment safety. The first one is make sure to wear gloves when handling the hot beaker. Second, handle all the equipment with care, especially thermometer that contains mercury. The third is make sure you use the right equipment for the experiment. Next, I will present about the references. So, this is all of the references that we use to run this experiment. And I think that's all from our group. Thank you.